Hi everyone, welcome back to Pine Hollow Auto Diagnostics. Today we have a 2010 Buick LaCrosse V6. Owner brought it here because he is frustrated with the local shops. They cannot figure out why his ABS and traction lights are on. So first, he took it to the dealer. The symptoms are, he said once in a while the ABS would activate on its own. Just you're driving along, not pressing the brake pedal, and you would get the activation. So he took it to the GM dealer here, and they scanned it, I guess, and they quoted him almost $2,000 because they said they needed to rip apart the whole interior, check out, the steering angle sensor and the yaw rate sensor, all this stuff for the traction control. So then he took it to a local independent shop. They scanned it, and they're like, hey, this is your problem. Your steering angle sensor is bad, and your yaw rate acceleration sensor is bad. Replace those. I think they even used aftermarket parts. Obviously didn't fix it, so the owner brought it back and like, hey guys, I already spent over $1,000 here. Can you actually fix my car? And they stopped returning his phone calls. So that's very frustrating. That's unfortunate that he had bad experiences at the dealer and at an independent shop. So let's try to figure this Buick out. I scanned it for codes, did some homework. Let's see what the codes are and do the actual diagnosis. Okay, so I have the full pre-scan saved on the ThinkTool Platinum S10, and right here I have it downloaded to my computer. So, EBCM. We have a U0073 control module communication bus A off, malfunction. 74. And then U0126, lost communication with steering wheel angle sensor module. Okay. U0125, lost communication with multi-axis acceleration sensor module. And then C0196, yaw rate signal. So let's pull up a diagram of the information bus. How does this EBCM talk to these sensors, and figure out why are both these sensors offline? Okay, so this is the OE diagram for the information bus. So it's a separate bus from the EBCM, that's the ABS module, and that talks to various chassis sensors, suspension control, there's rear differential, steering wheel angle sensor, and multi-axis acceleration sensor. Now, keep in mind, you have to look at the RPO codes to see which module this car is equipped with. This is a front-wheel drive, so we won't have the rear differential module. So always take a picture, if available, of the RPO sticker. So it lives in the trunk on this car. I did that. And let's see, are we equipped with F45 or F46? We have E, F, FAI, FBM, FX3, no F45, no F46. So this is the kind of the base model. So just 3 modules on this network. EBCM, the DLC, it goes to pins 12 and 13. So this is kind of a sub, it's a CAN 2-wire network just dedicated to these 3 modules. Steering wheel angle sensor and multi-axis acceleration sensor. Note we have these pairs of 60 ohm resistors, terminating resistors, one in the EBCM, one in the multi-axis acceleration sensor. So this is fantastic. This diagnosis shouldn't take too long because we have 3 modules and we have access at the DLC to measure these terminating resistors. I want to see, is this network sound? Are there any breaks in the wires? And is it shorted to ground? Is it shorted to power? What is going on? So we'll start with just an ohm meter and a voltmeter at the DLC without taking anything apart just yet, and see where this goes. So let's go to the car. So the car's off. It's asleep, but we don't have the battery disconnected yet. Let's see what readings we get on pins 12 and 13, just across pins 12 and 13 on the ohm meter scale. Look, it's showing 0.0. So are these wires shorted together? Be very careful about this measurement. What is the voltage across these pins. 0.8 volts. So the system is either not asleep or there is another problem. So you want to start with the voltage measurements. Let's measure from pin 12 to ground. So pins 1, 2, 3, 4, and 5 are going to be grounds. Look at that. We have 3 volts on this network wire right now on pin 12. What about on pin 13? Oh, did it go to sleep? It's showing 0 right now. Right as we're measuring, the car might have timed out. Now we only have 4 millivolts. So I think now we can do our resistance check. See, there's 0 millivolts between those 2 pins now. Right there. So let's go to the resistance reading. 61 ohms. So that tells me, hey, we don't have any broken wires all the way from here through these terminating resistors and coming all the way back to our meter on the other pin. So that's good. Now, keep it in the ohms scale. Let's see if this network might be shorted to ground. So let's move one of the leads to pins 4 or 5, doesn't matter. 15.5 kilo ohms. Okay, that's not terrible. You can measure from the other. 14.98 kilo ohms, so about 15 kilo ohms resistance to ground. Okay, that's fine. Let's go back to volts. Make sure from pin 16 we have good battery voltage. We're not shorted to power anywhere. That's good. So in this case, the ohm meter didn't show us anything conclusive. Now, the customer said that this problem is intermittent. You know, the car remembers the faults, but it's not necessarily a permanent fault. So what I want to do now is hook up an oscilloscope to both can high and can low, pins 12 and 13, and take this car for a test drive. Maybe there's, you know, an intermittent wiring problem somewhere as you go over bumps. It might glitch and set the codes. We'll erase all the codes, hook up an oscilloscope, take it for a test drive, and see if we can recreate this fault. Because right now, it looks like the car is happy, and if we clear the codes, they shouldn't come right back just sitting here in the garage. Okay, so I have the breakout box connected in 2 channels on the picoscope. So let's see what this network looks like. So everything's off right now, and the scanner piggybacks off of the breakout box. So let's turn the key on. Let's see. Okay, there we go. We have some kind of signal. Keys on. Does that look like a good signal? Well, it looks very, very busy on this network. So let's decrease the time base and zoom in. So this tells me nothing's wrong with the wiring or the voltages. So as you can see, about 1.5, and this one goes up to 3.5, the bias is 2.5. I mean, that's great. We can even decrease the voltage scale. Everything looks great. But the pattern is something's just talking, can't communicate. So let's zoom back in, or zoom back out. So I don't like this. Let's clear the DTCs. See what codes come back. So right now I'm suspecting an actual module failure. So EBCM is 1 code left. Let's see what that is. Oh, I guess it's still, there we go. Control module communication B bus off malfunction. System information disabled. Yep. So it's, let's scan it one more time and see if the sensor communication faults come back, because they're on that bus. This is a bus fault. You know, electrical fault, not a mechanical wire pinched or something weird going on. Okay, well, I guess when I was talking there, go back in. So we'll pause that. And then parking brake control module says system disabled information stored. So we're worried about this control module communication bus B off malfunction in the EBCM. So how do we attack this problem? We're suspecting one of the modules on this bus is just taking over the network and interrupting what the other two have to say. So EBCM, steering wheel angle sensor, and multi-axis acceleration sensor. Let's look up wiring diagrams. You know, we can either disconnect these sensors, but they could be buried, you know, under the console, in the steering column. We want to work smart here and maybe disable power to each one of these one at a time and see what happens to our network. If it comes back, then we know to go after whichever one we disabled power to. So there's only 3 modules here, and I think this shouldn't take too long. So let's look up the wiring diagram for the steering wheel angle sensor, the entire view, and also the multi-axis acceleration sensor. Okay, so I went and looked for wiring diagrams of this traction control system, and multi-axis acceleration sensor, 4 wires, and the power comes from directly from the EBCM. So you can't just pull a fuse and disable power to this thing because the EBCM is in charge of it. Same with the steering wheel angle sensor. 4 communication wires and then power and ground. So very simple. But how do we disable these sensors one at a time? That's what I want to do. Well, you can see this one, there's an X200 pin 7. Maybe we can disconnect that to get the steering wheel angle sensor out of the way, or I can look up how to get to it. Maybe it's not too hard to pull this cover off and just unplug it. Alright, so here's the steering wheel angle sensor, and it piggybacks off of the airbag coil spring, the what do you call this thing? Right behind the steering wheel, clock spring. So I don't know if it has a separate plug on it. I think it does. So I just want to unplug it. That's the only thing I want to do. I don't want to remove it. So let's take this cover off the column and see if we can unplug it. Okay, so only took a couple minutes to get the steering column cover off. Sure enough, here's our steering angle sensor, and this is supposedly aftermarket. Okay, so what do we want to do? Let's turn the key on and look at the network signal, and then unplug the thing. And see if this changes. Let's try it. If I can figure out how to unplug it. You guys are going to have to deal with the dinger. There we go. No change there. So what did we do on the wiring diagram? Get that out of the way. So now the terminating resistor, so we basically unplugged this, and this is out of the picture, and the multi-axis acceleration sensor is also out of the picture. However, we're measuring right here, so the only thing left on this bus is the electronic brake control module. And I'm not happy with this signal right there. It just keeps repeating over and over and over again. Exact same pattern, like it's reaching out and asking, hey, are you there? Are you there? And I guess neither this, the steering wheel angle sensor, or the multi-axis acceleration sensor are responding. We know the network is continuous, 60 ohms. There's no broken wires, the connectors are fine. So, is it looking like a bad EBCM, electronic brake control module? At this point, it is. Let's think of any other variables that can come up here. Because we don't want to condemn this. This is the expensive piece. These have already been replaced. That didn't work. And are there any other variables? One variable that I thought of is, well, are these two sensors powered up? Because we saw that the power comes from the EBCM on that green wire, right? So right here, dark green wire, straight from the EBCM. Do we have 12 volts on there with the key on? Well, let's check. We already have the connector. There's the green wire. So, keys off, 31 millivolts, that's fine. Turn the key on. No change. Well, isn't that interesting? Let's make sure our meter works. I'm going to touch it to the breakout box positive pin. Yep, 12 volts. We have nothing on this green wire. How about that? What's the next step? Well, let's use a small test light and provide 12 volts to that green wire. So from battery positive to the green wire. Maybe there's a short, and if it's pulling that line down, potentially the EBCM could have a current limit in here, and then the voltage doesn't even make it to these two sensors. So a really safe way to check this is, this is unplugged. We'll take a test light from battery positive, plumb it into here, and if it lights up, that's not good. That means that there's too much current being drawn somewhere along this power feed line. Or maybe it doesn't light up and these two sensors come back online and everything works, then we're chasing either a wiring problem on this power feed tree from the EBCM, potentially. So let's do that quick check. Okay, so little baby test light, 300 milliamps from battery positive. If it finds a ground, see it lights up. So we're going to attach this right to the green wire. We'll see what happens. Now, no, we're not going to cook anything. That is a 12 volt feed, so we're just making it 12 volts. Test light's not lighting up. Let's turn the key on. And we'll see if the ABS module starts talking to anything. So about the same pattern, but keep in mind this is unplugged, so everything, all the other sensors are offline. Check this out. Now we're in business. See the data packets? Now the bus isn't all confused. So let's back out. See how different that is? It's actually talking. And I'm sure that if we start up the car, let's clear out all the codes. Look, no codes in the EBCM. No codes in the parking brake. Let's start it up. No traction light. Everything's happy. Now what happens if I disconnect my test light? Test light's disconnected. Let's throw the voltmeter back on there. Do we have 12 volts on that wire? Look, we have battery voltage on that green wire now. What just happened? Let's try again. So key off, key out, goes to 0. We have this. Key back in. See, no power. No power is going to set the service stability track, I'm sure. Same nonsense. Oh, okay, now we got power there. Service stability track. Scan the EBCM for codes. So we're definitely on the right track. Read fault code. There it is, U0074. And look what's going on with our voltage. That's pretty crazy. There you go. Okay, now it's battery voltage. We're happy. Let's keep waiting. Is it going to drop out? Press the brake. Press the gas. Well, it seems to be okay. Still have communication. There's something wrong with that power feed. Intermittently. Key off. Key out. Communication's still good. Okay, now we're off. And we're off. Key back in. Communication's good. So that time it was fine. Now we're still fine. Communication's still okay. So what would be your next test in this scenario?